clarity.
So you're welcome once again. So who was in class last week and what did we discuss? Hello? I don't know why my camera is so blurry. I guess I can still manage with it. Last week, who can tell me what we discussed?
Actually, I was not in the class, but I went back to check. I think we should talk about oscillation and simple harmonic motion.
These are third class.
Really?
Hello?
Yes, sir. Yes, sir.
Yeah, I'm trying to see something. I guess we had our first topic. We had our first major class last week, right? In which we talked about I'm trying to check so that I won't just mix things up. Okay. Last week we talked about simple harmonic motion and bodies performing simple harmonic. Let me project that. I'll put that on the screen now. One. So we talked about last week. We talked about simple harmonic motion, and we were able to talk about define oscillations. We discussed about bodies performing oscillations. We mentioned velocity and acceleration of SHM. Also, we also mentioned the first law for simple harmonic motion, and I gave a summary of this table where I said that this is just a summary of bodies performing simple harmonic motion, their inertia factor, simple factor, the angular frequency, and the period of oscillation. But this week we'll be talking about another topic, which is the second topic in the outline, which is let me project that. Oscillation on waves, that's the first topic. So we'll be talking about principle of superposition. And at the end of this lesson, I said last week that you should practice the questions in the course material. As you are all aware, the course material, I guess, is quite voluminous. Let me try and open that. Let me try and open that. The course material is quite voluminous, 237 pages. So we can only touch the ones we can. So it is advised that you go through the, I think we are on page 20 now, thereabouts now. So practice those questions there. Then any gray areas, I hope you can all hear me.
Yes.
So you practice those questions, and if there's anyone that you are not getting, you come back to class. I actually gave an assignment, and nobody attempted it. I gave an assignment last week, I can remember now. So for the first class, we covered even up to page 36. We We covered up to page 36 of the course material. So if you are going to read up the class you did not join, you need to read up to page 36, because on page 37 here, we have superposition of harmonic oscillations, and that is what I have to study today. So now, let me stop this here. So let's go to the last class. We actually give an assignment, and let's go to the assignment. Let me bring it up. I think I did. Is it not this class? Or it's 207? I'm very sure in one of those classes I gave out. Okay. I don't think it's this class, but don't worry. Practice the questions on page 30. Okay, it's here. Yes, I can remember. This is it. Can you see it? Can you see the question?
Yes, yes, sir.
I was told I told you to solve this question and get back to me and drop it on the WhatsApp group. I hope you've all dropped your number on the WhatsApp page. On the chat menu, rather. I hope you've all dropped your numbers so that the
yes, we have.
Create the WhatsApp group. So, okay, for the sake of those that didn't join the class, the video for this class is on the portal of PHY406, and the video of last week is on YouTube as well. You can just search PHY406 on YouTube. The link is on the portal as well. You can copy it and watch the class. You can actually watch each of these classes later because it is being recorded and uploaded. Is that clear?
Yes, sir.
So basically, that's that about it. Please, everybody should copy this question. You can screenshot it, then you answer the questions. You must drop it on the WhatsApp group. I will ask immediately I'm done. So I will give you till Friday to drop it there. And how many of you are still taking PHY407?
I am, sir.
Who is that? That's Annie, right?
Yes,
Yeah,
Annie, I'm taking to 207.
and Ebenezer also.
Okay, and Ebenezer, you know the class holds every Thursday.
Same time?
Yes.
Okay.
We are going to the third or fourth week already, and I don't think I've seen Annie join the class. So
No, this is my first class, actually.
Okay, it seems you just registered.
No, I didn't. I registered, that was my 100 level first semester, but I got the email today, so I was even surprised when I saw it.
No, I've been sending emails, even the one for last week, the previous week, I've been sending mails. So you've not been getting that?
No, I just got this one for today.
What about others? Have you been getting my mails?
No, I've not.
No, others. What about others?
At all, I've not been getting any other one.
No, I mean others that are joining us today. Have you been getting our mail?
Okay.
No.
I'm talking
No,
to
sir.
Ebenezer.
No, sir.
No,
No, sir.
no.
Have you not been getting our mail? How come you now join the class today?
I just
From the
received the
portal.
mail.
You said what?
I went to the portal, the e-learn portal. That's how I got.
Are you saying, because I seem to have your email, that means the one there are not correct. Who is, I know that I have Miriam Abba Aminu at gmail.com. Is that your email, Miriam Abba? I think she has left the class. Then
Sir, I check it now. You sent the mail already. I didn't check, sir.
What about previous week? That means you've not been checking too. You've not been checking too. Then okay, your mail is vanuseze
Yes, sir.
at yahoo.com.
Yes, sir.
I've been sending it. So you should be receiving mails from me at least once a week.
I do receive, but the hindrance is there is data.
Yeah.
Data. Yeah.
Very big man. She will be able to get that. She will be able to get that. Data is small compared to what you pay for school fees. And you know, very
I know.
soon, TMA will start. And it
I
is
know, sir.
you and you alone. So it is better for the student I taught the last time, they all passed. So it is my joy that everybody should pass. So it is the only thing we can do with ourselves is to go through this material together. Normally, it's not a teaching, it's not like the conventional teaching. The normal practice is that students should come to class, we share this material together. Then you will read the material, then you come to class with the gray areas. To come to class with the gray area. So basically, you should read the end of the class. At the end of the day, you'll be happy that, okay, I joined this class and I benefit so much from it. So without wasting too much time, let's go back to the class. Going back. Let me stop sharing. Good. So let me just project what we have today, which is topic 2, which is superposition. So put it here that, can you see the screen?
Yes, sir.
Good. I said intended learning outcomes. At the end of this lesson, students should be able to describe and state the principle of superposition, apply the principle of superposition to 2 harmonic oscillation of 1, the same frequency, and of B, different frequencies along the same line. Apply the methods of vector addition and complex number for superposition of many simple harmonic oscillations. And lastly, apply the principle of superposition to mutually perpendicular harmonic oscillations of different frequency or phase, and describe the formation of Lissajous figures. Now, what is superposition? Now, we said, I wrote that for many practical applications, we have to deal with a combination of 2 or more harmonic oscillations. Now, we said our hair drum receives a complex combination of harmonic oscillations. In order to obtain the resultant effect of 2 or more harmonic oscillations acting on the body, we have to make use of superposition principle, which states that the resultant of 2 or more harmonic displacements is simply the vector sum of the individual displacement, which is known as the principle of superposition. When we talk about superposition, is the addition resultant of two or more harmonic displacements. You understand? It's by hiding their individual displacements, and that you would have clearly defined what's it called? Superposition. Can you all see this? Can we read it together? It says that the resultant of 2 or more harmonic displacement is simply the vector sum. Can you see?
Yes.
Yeah.
The resultant is the vector sum of the individual. So if there are 3, you add them together. This is the principle of superposition. Now, we are going to now look at it from different perspectives, the ones that have the same frequency and the ones that have different frequency. Now, we said superposition of 2 collinear harmonic oscillations. And we said oscillations having equal frequency. So we said, suppose we have 2 SHMs of equal frequency, but having different amplitude and phase constant acting on a system in the XY direction or in the X direction. The displacement X1 and X2 of the harmonic motions of the same angular frequency W differing by phase theta are given by, now look at these 2 equations. This first one is simply A1 sine omega t. But since the X2 is equal to A2 sine omega t plus a phase difference, a difference in phase. So now, by applying, and they have the same frequency, this omega and omega are the same. By adding this, we are simply saying that it's the vector sum. You know, we define that the vector sum of two harmonic oscillators. Now, the vector sum should be x equals to what? X1 plus x2, which will be equals to a sine omega t plus alpha.
Alpha.
Can you see? Since they have the same frequency, so it's as if two becoming one. So now, looking at this equation now from the next slide, we have it to be a1 sine omega t plus a2 sine omega t. It's like you are bringing the two together. You are bringing equation 1 together with equation 2. And if you do that, this is equation 1 multiplying equation 2. So if you do that well, you have this, which is a1 sine omega t plus a2 sine omega t cos the phase difference plus a2 cos. Actually, what they applied here was what we call sine rule. Is that clear? Now, if you have
Yes,
something
sir.
like this, let me go back to this slide. Let me go back to this slide. Now, this is sine rule. Now, if you have something like this in sine rule in mathematics, sine rule is sine A plus B. So it would be the sine rule will now be sine A cos alpha plus cos A sine alpha. In those days, I can remember we actually formed it to be sin, cosine, can you see? Sine, cosine, cosine, sine. So when you open this up, it will reduce to what's it called? C sine W omega t plus D cos omega t. Because when you collect what's it called? Like terms, what is constant with these two is, now look at this. Can you see this? A1 sine omega t plus A2 sine omega t cos alpha plus A2 cos omega t plus sine alpha. Now, which will be equals to, now we are now trying to connect like terms. A1, A2, A1 sine omega t is common to this side. So we bring out sine omega t. So we are left with A1, the sine omega t is out. A1 plus A2 cos phi, which is sine omega t. Then at this other end too, we have cos omega, what's common to both sides? We have what's common to this other side? A2 cos sine omega t, cos omega t is brought out. So now what you now have is A1 plus A2 cos alpha plus A2 sine alpha. We now say that A1 plus A2 cos alpha to be C, then A2 sine alpha to be D. So that will now reduce this equation to both sine, sin sine omega t plus D cos omega t. I don't think anybody will really ask you to prove this. But what you just need to note is the final derivation. But we're not done with the derivation. So it continues from the next slide, which says that A equals to C squared plus D squared. And A, from what we have here, we substitute the value of C and D into that equation. If you do that very, very well, what you have is A1 squared plus square of A1 plus square of A2 plus 2A1 A2 cos alpha. If you open up the bracket, where I mean this bracket here, this bracket here. What they just did was C and D multiplying each other, because we said that A here is C squared plus D squared. So we are squaring this value. Where is it? We are squaring this value. This. So we square this. A1 squared plus A2 squared cos omega t, then A2 squared sine omega t. So by the time you do that, you'll be left with this. So this is the expansion, and you have this. So A will now be A sine omega t plus alpha. So this is the final answer. Now, this shows that the resultant of two collinear simple harmonic motions having the same frequency is itself a simple harmonic motion. So two collinear simple harmonic motion having the same frequency is itself a simple harmonic motion. The difference is just that the amplitude and phase of the resultant SHM this depends on what? The amplitude, which is the A of the two individual SHM, as well as their phase difference between them. So it depends on the A and the phi A. Is that clear? So these are the two. So when you had two collinear oscillators, harmonic oscillators together, the result you get is a simple harmonic motion or oscillator as well, in which the difference is just that the A here will be a product of the two harmonic motion or oscillator, collinear motion, harmonic motions, then by addition of the phase difference. Now, moving forward, we have it to be, so the resultant will now be 2A sine W1 omega 1 plus omega 2 over 2 cos omega 1 plus omega 2 t over 2. Then this is an oscillatory motion with angular frequency of this and amplitude of this. Now, what we're trying to say here is that the amplitude of two oscillations are the same. So in the total summary of what we are saying is that the amplitude of the two oscillations that have the same frequency, they are the same, and the phase difference is what? 0. So this is just the summary of what we've been saying all this while. And what I will advise you to do is you should check online for past questions so that you will know how your questions are set, so that you will get to the exam and see something quite different. So let's quickly go on because we have just less than 10 minutes more. So I said students should read up oscillations in 2 dimensions, and which is superposition of two mutually perpendicular harmonic oscillations of the same frequency and superposition of two rectangular harmonic oscillations of nearly equal frequencies. Because it is voluminous, I can't bring it to class. It will take a whole lot of our time. So what I just did is the form of introduction to that piece. Let me project the course material itself. I'll stop sharing this now. The course material itself is this. Where is it? Okay, this is it. Now, this is the course material. So you are expected to study, to have studied at the end of this class. You should try and study from the beginning to, these are the things I've been saying since, but I cannot bring out everything in the class. So this is the X1 and X2, and it became this. It became this. Now, looking at the material, we have talked about all this. I've just summarized what and what is in that in this material there. And this is what I was saying. This is cosine rule. If you have anything cos A plus B, it will be cos, cos, sine, sine, cos A, cos B, minus sine A, sine B. And we have the sine odds, which will be sine A, which is sine A, sine B, cos A, sine B. So you should note this, and also note, let me see if it is in this material. Okay, it is just note that particular equation, this one, so it will help you. I don't think anybody will ask you to prove all that, but if need be, you need to just learn it. But the final answer is of SS, which is this, which is,
Hello, excuse me, sir.
yeah,
Excuse me, sir.
yeah,
Based on the cosine rule you said and the sine rule, based on the derivation of the formula of oscillation of the same frequency along the same line, I think that thing is a trigonometric ratio of compound angles.
yes, you are right. It is in mathematics. Yes, you are right.
Okay.
Yes, you are right.
Because it gets me confused.
No. It's still the same. That's what I'm trying to say. For the good student of mathematics, they will understand what was done there. It's an expansion. It is a trigonometric function of, I think, we even had one of half angles. So for mathematics students, they should be able to solve all that. So it is expected that you should even study up to page all of this. So by the time you study, you come to class. What I just did was just to wet your appetite. I just show you one or two things. So it is expected that you should read up to page, let me see. Because the course is quite voluminous, 237 pages. Even you have to read all this, even to page this is 53. So try and read the ones you can read, jot them down. The one that's not clear to you, you bring it to the class, or you introduce it on the WhatsApp page. You throw up the questions and you look at the summary. In fact, the summary is always helpful. So if you have the summary goes straight to the point. And by the time you practice the terminal questions that are stated here, you will have gotten an idea of how questions are being set in these questions. And it runs up to page 60, up to page 64. So it is in the new topic I'm going to take is damped oscillation. In fact, that was what I projected initially, but I had to remember that we've not touched the other one. So it is expected, although they didn't number this one, this is not 199, this is page 64. Look at the page number up there. Can you see the page number up there, page 64?
Yeah.
Good. So it is expected that you should study up to page 64. So if there's any area, this is not a conventional class that we just teach everything. Students are supposed to read ahead of the class, and any gray area they have, they bring it, we deliberate on it. But the reason why I had to introduce that is that the reason is that you have not read ahead of the class. So I just have to just pick out one or two things, and we have limited time. For example, now the Zoom app will go up in less than 4 minutes. So we have a very limited time to start explaining those equations, and it is best taught writing on the board. So basically, what you're just doing is a facilitation class, not a teaching class. So go through the materials, page 1 to 64. If you have any gray area, any area that you don't understand, you bring it to the class, we trash it together, and we proceed to the next topic, which is what we call damped harmonic oscillation or damped harmonic motion. So I would like to take questions from you now. We have less than 3 minutes. Any question from anybody?
Hello.
Yes, I can hear you.
Now going to the principle of superposition,
Okay.
you know, when the two waves come together, you
Yes.
add up their resultants.
Yes.
Then by adding up the resultant, I believe that there will be in a situation where there will be a kind of the resultant not being equal to. That is, what do I mean by that? That is, there will be a kind of a type of that superposition. Whether there will be
Yes, when they
constructive
come
or
together,
destructive.
you know, one is ahead of the other. Is that also? You can see that
Yes.
the first question was A sine omega t. Then the other one was A sine omega t plus a psi. That is the phase difference. No, by the time they now come together, it will not be as if it is that of that second one that has a phase difference, but the amplitude is different. It will have a higher amplitude. Is that clear?
Yeah, is there a situation where they will have lesser or zero amplitude?
It is when we not talk about a different frequency. That is part of what I said you should read on.
Okay.
It is part of it. That is one of the, I can't just bring everything to class.
Okay, sir. So,
by the time you now come to class, you read that, you can throw that open, even on the WhatsApp page. We all deliberate on it. So by the time you are even if they're in a different direction, there will be problem.
yes.
So I like that. So basically, you should read up next week. The first 20 or 30 minutes, we will dedicate it to. In fact, we might have, even if the Zoom class should go off, we will relaunch it and we'll start all over again.
No, we have other things to do.
No, if we really have the time. Yes,
we have other things to do.
But I'm just trying to, I have the time. I'm just considering the fact that the time is not always on our side when it comes to situations like this. So it is advised, strongly advised that students, people should go through this material from the page 1 to the 64 here. So if there's any question, we bring it to the class. Then by next week, we go through that. If there's no question, we just go straight to damped harmonic oscillation. And you are aware of the fact that we just have 8 weeks for this. The first week is always introduction, and the last week is always for revision. So invariably, we just have 6 weeks together. So this class today is the third class. Sometimes we have about at least, let's say, 4 more before the revision class. So it is. Yeah. So it's nice meeting you people. Please, the person I said should form should do that, so that we'll be able to interact from there. The Zoom will go off anytime from now. So do have a lovely day ahead of you.
All right.
All right. Thank you.
You too.